can have a good score in your exam starting from tomorrow. So let's go and see what you can get from the set of questions. So let's continue. Pay attention. So let's look at this particular question here. You say the treated water usually used in swimming pools. So there are different substances used in treatment of waters in swimming pool. Like we use alum to coagulate water particles. We use chlorine to kill germs and other substances. So the answer to this question is chlorinated water. Reason, or using chlorinated water to kill germs. That's why we use chlorinated water to kill germs in the water. I go to the next question. So what we have here is a different question. This one says, say the total number of proton and electron in a neutral atom is 38. You say the mass number is 39. Say the mass number is 39. They're now asking us calculate the number of neutron. Calculate the number of neutron. Now, it says the sum of proton and electrons. Say the sum of proton and electrons in a neutral atom. In a neutral atom, proton is equals to electron. Proton is equals to electron. So that means if each of them is now what 19. That's the only way they say the total of proton and electrons. So for a neutral atom, proton equals electron. So if the both are the same, that means each of them will be 19. The proton is 19, the electron is 19. 19 plus 19 will give us 38. So if the 38. So if the mass number is 39, what is the number of neutron? We know that proton is equals to the mass number, which is 39. So if the proton is 19 plus the neutron, that will give us 29. It simply implies that the neutron is simply 39. It simply implies that the neutron is simply 39 minus 19. The answer will give us 20. So option A is the correct answer. Please take note, this can only happen for a neutral atom, meaning an atom with no charge, such as sodium. This is sodium ion. It's different from when you are dealing with an ion. This is just a neutral. Electrons are the same. So that is how to deal with a situation like this. Proton and electrons are the same for a neutral atom. So let's go to the next question. You say, what type of bond is between sulfur and oxygen? So remember, sulfur is a non-mental. Sulfur is a non-mental, and oxygen also is a non-mental. So when two non-mental comes together, the bond is formed is covalent bond that is formed for two non-mentals is covalent bond. So that's the answer to that. Let's go to the next. So the scientist discovered the electron in negatively charged particle. The scientist who discovered the electron in a negatively charged particle is J.J. Thomson. I believe everybody should know that, J.J. Thomson. Here we have another question. So what we have here is which factor, the factor that will affect the rate of a gaseous reaction. The factor that will affect the rate of a gaseous reaction. So when we talk about a gaseous reaction or aqueous solution, we are having pressure. We are having pressure. This is deals with temperature, which is in that enthalpy change, either endo or exothermic reaction. Surface area deal with the nature of the particle, such as whether it is solid or a grounded particle. That's why we have surface area. Then when we talk about concentration, we're talking about the addition of more of the substances to either the reactant or the product. So for a gaseous product, you are dealing with pressure. Gaseous or aqueous, that is when pressure is applied. Please take notes. Gaseous or aqueous, pressure is involved. Number 21, we have, say, a sodium ammonium nitrate to form sodium nitrate, water, and ammonia. So the reaction above is used to test for what? What is used to test for? The reaction above is used to test for ammonium solution. You can see we have ammonia as the product, as the gaseous product, and the end of the day is to test for ammonium solution. We have a different question here. Said, a salt that crystallizes, what of crystallization? A salt that crystallizes with water of crystallization. We have a copper sulfate, we have copper sulfate, calcium, we have a calcium carbonate, we have calcium carbonate, we also have silver nitrate, and finally we have sodium chloride. So we saw which crystallize. So the question is, what is crystallization? With what of crystallization is the ability of that salt to absorb water content at a particular temperature. So the answer to this question, the only one that has the ability to crystallize here is copper sulfate, not this one the person marked. The answer is copper sulfate. Next, we have, say, a salt, example of a salt that's partially soluble in water will be what? A salt that's partially soluble in water. We have calcium sulfate. We have magnesium sulfate, we have potassium sulfate, and finally we have sodium sulfate. So we have substances that are soluble, some that are highly soluble, while some insoluble, and some are partially soluble. So we are talking about a solvent that's partially soluble now. That means it's not completely soluble and it's not completely insoluble. So magnesium sulfate, which is also called MC salt, is soluble in water, very soluble. Then we have calcium sulfate also. Is also okay. We also have calcium sulfate, we have magnesium sulfate, sodium sulfate, and we have calcium sulfate. So all so the solution to this, all these mentals here, group 1 and group 2 mentals are soluble. Even though calcium is also a group 2 mental, it forms an insoluble solution with H2SO4. So therefore the answer is calcium sulfate. Say a salt of silver of trans 5 that does not produce brown fumes of nitrogen oxide. That's the color of nitrogen oxide, is brown fumes. Nitrogen oxide has a brown fumes. That's the color. Undecomposed on heating. So the answer, this will produce except silver. Silver will not produce brown film coloration when heated. A compound of nitrate of silver will not do so. So iodine dissolved in ethanol is widely used in what? Don't forget, an iodine is in group 7, such as where you also have chlorine, iodine, and astacine. So when we dissolve iodine in water, what can we use the product for? Is it an oxidant, antiseptic, a germicide? Don't forget we discussed the question earlier when we said chlorinated water is used as a germicide in swimming pool or as a refrigerant. So the answer is not close to refrigerant at all. So the answer is not germicide. Chlorine is primarily used for that. It's not an oxidant also. The answer is antiseptic. That is what iodine is used for when it's dissolved in ethanol. Next, the conventional preparation of hydrogen can be used by what? So we have preparation and we also have commercial preparation. For reaction A, B, and C, those ones they are laboratory preparation of hydrogen. The commercial preparation of hydrogen is gotten from iron reacting with steam. This is steam. When iron reacts with steam, is used as a commercial production of hydrogen. 1, 2, and 3, they are laboratory preparation of hydrogen. Next, say the gas that can be dried. I'm currently experiencing network challenges. I'll come back later in the evening when the network is stable. So hope to see you next time this evening.